Hi everyone. We're going to take the derivative or find the limit of a piecewise defined function. Here we have a quadratic for the first piece for x is less than 1, and we have a linear function for when x is greater than or equal to 1. We're going to use the difference quotient here, and we're looking at where x sub 1 equals 1. So we're going to be plugging in 1 into our values here. So this would be the formulas we're using for both pieces of the function. I went ahead and took the liberty of graphing this. There's our 1 here. So, and I graphed the side left of 1, which is a quadratic, 3x squared. And it's open circled. However, at 1, when you plug in 1, it goes to 3 as well. So closed here overrides 3. So you can see, looking at the graph, this is smooth and continuous with no sharp curves. So let's go ahead and take the limits. And we're going to take the first one, which is going to be, we're going to look at the positive side. So that's going to equal the limit as our change in x approaches 0 from the right side. So it's going towards the 1. And that's going to be 6. And our x is 1 here. So it's going to be 1 plus change of x minus our f of x. So recall this one was 6x minus 3. So what we're going to do is plug in 1. And that gives you minus 3 here. All over our change of x. So we're going to clean this up a bit. And that's going to give you 6 plus 6 delta x minus 3. Oh, I should have put minus 3 up here. Sorry about that. That's what I did last time. Okay, so this could be minus 3. And then this is your negative. This is your positive 3. So it's going to be minus a positive 3. All right, so we get minus 3 over our delta x. All right, so basically we're going to get the limit. Delta x approaches 0 from the right, and these will cancel. So you get 6 delta x over delta x, and that equals 6. Okay, whereas when we take the limit from the left side, we're going to write f derivative from the left side. So that's going to be limit delta x approaches 0 from the left. And we're going to use 3 and our 1 plus delta x squared minus f of 1. So f of 1 equals 3 times 1 squared. So that's just going to be minus 3 all over delta x. All right, and you clean this up. We're going to get 3. Wait. We got to clean this up. So we're going to get, I'm going to go ahead and take care of this as 3. And go ahead and FOIL that out. So that's going to be 1 plus 2 delta x plus delta x squared. And then we have the minus 3. All right, so this equals the limit delta X approaches 0 from the left and distribute. 3 plus 6 delta x plus delta x squared. 3 delta x squared minus 3 over delta x. All right, and what happens here is the 3's cancel. I can factor out a delta x. So when I do that, I'm going to get 6 plus 3 delta x over delta x. So these two cancel, and when you plug in 0 here, that's going to cancel that out, so it equals 6. Therefore, since f, the derivative of f from the positive side of 1 equals 6, and that also equals the derivative of f from the negative side, we get 6. That means the limit exists at the derivative at the derivative of f at 1. That means the limit exists. Thank you. Have a nice day. Bye-bye.